You're just walking down the street and someone comes up to you and says, quick, quick, 4,792. Is this divisible by 3? This is an emergency. Tell me as quickly as possible. And luckily, you have a little tool in your toolkit where you know how to test for divisibility by 3. You say, well, I can just add up the digits. If the sum of that is a multiple of 3, then this whole thing is a multiple of 3. So you say 4 plus 7 plus 9 plus 2. That's 11 plus 9 is 20 plus 2 is 22. That's not divisible by 3. If you were unsure, you could even add the digits of that. 2 plus 2 is 4. Clearly not divisible by 3. So this thing right over here is not divisible by 3. And so luckily that emergency was saved. But then you walk down the street a little bit more and someone comes up to you, quick, quick, quick. 386,802. Is that divisible by 3? Well, you employ the same tactics. You say, well, what's 3 plus 8 plus 6 plus 8 plus 0 plus 2? 3 plus 8 is 11, plus 6 is 17, plus 8 is 25, plus 2 is 27. Well, 27 is divisible by 3. And if you're unsure, you could add these digits right over here. 2 plus 7 is equal to 9. Clearly divisible by 3, so this is divisible by 3 as well. And so now you feel pretty good. You've helped two perfect strangers with their emergencies. You figured out if these numbers were divisible by 3 very, 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 very quickly. But you have a nagging feeling because you're not quite sure why that worked. You've just kind of always known it. And so let's think about why it worked. And to think about it, I'll just pick a random number, but we could do this really for any number. But I won't go too proofy on it, just so that you can see it's pretty common sense here. And the number we'll use is 498. I could literally use any number in this situation. And to think about why this whole little tool or this little system works, we just have to rewrite 498. We can rewrite the 4, since it's in the hundreds place, we could write that as 4 times 100. Or 4 times 100, that's the same thing as 4 times 1 plus 99. That's all this 4 is. It's 400, which is the same thing as 4 times 100, which is the same thing as 4 times 1 plus 99. And the little trick here is that I want to write, instead of writing 100, I want to write it as the sum of 1 plus something that is divisible by 3. And 99 is divisible by 3. If I had more digits here, 999, 9,999, they're all divisible by 3. And this is why you can do the same reasoning for divisibility by 9, because they're all divisible by 9 as well. Anyway, that's what that 4 in the hundreds place represents. This 9 in the tens place, well, that represents 90, or 9 times 10, or 9 times 1 plus 9. And then finally, this 8, that's in the ones place, that's just 8 times 1, or we could just write plus 8. Now, we can distribute this 4. This is 4 times 1 plus 4 times 99. So it's 4 plus 4 times 99. Actually, let me write it like this. I'm going to write, well, actually, let me write it first like 4 plus 4 times 99. Do the same thing over here. This is the same thing as plus 9. Let me do that magenta color. Plus 9 plus 9 times 9. 9 times 9. And then finally, I have this 8 right over here. And I can rearrange everything. These terms right over here, the 4 times 99, and then the 9 times 9. I can write over here 4 times 99. I'll write it with slightly different notation, plus the 9 times the 9. That's those two terms. And then we have the plus 4, plus 9, plus 9, plus 8. Plus 8. Well, can we now tell whether this is divisible by 3? Well, these terms, these first two terms, are definitely divisible by 3. This is divisible by 3 because 99 is divisible by 3 regardless of what we have over here. You don't even have to look at this. This is divisible by 3, so if you're multiplying, it's still going to be divisible by 3. This is divisible by 3, so if you're multiplying, this whole thing is still going to be divisible by 3. If you add two things that are divisible by 3, the whole thing is going to be divisible by 3. So all of this is divisible by 3. And if you had other digits here, you would have done the same exact thing. Instead of having 1 plus 99, you would have 1 plus 999, 1 plus 9,999, etc., etc. So the only thing you have to really worry about is this part right over here. You have to ask yourself, in order for this whole thing to be divisible by 3, this part is, well, if that part is, then this part, in order for the whole thing has to be divisible by 3, that also has to be divisible by 3. But what is this right over here? These are just our original digits, 498, 4, a 9, and an 8. We just have to make sure that when we take the sum, it's divisible by 3.